In this concept, we're going to talk about exponential functions. An exponential function is an equation of this form, y equals ab to the x power, so the variable x is in the exponent, where a is not equal to 0 and b is greater than 0, and b is not equal to 1. Characteristics of an exponential function include the following. The function has to be continuous and one-to-one. One-to-one meaning every one value for x produces one value for y. Okay? That's one-to-one. The domain has to be the set of all real numbers. The x-axis is an asymptote of the graph. Okay? Meaning usually the curve does not touch the x-axis, right? Whether it's a positive exponential or a negative exponential, same thing, right? The range is the set of all positive numbers if a is greater than 0, and all negative numbers if a is less than 0. So what this looks like is just like this. So if you have a positive exponential, right, the range is essentially any y from 0, right, all the way to, infinity on y, right? Because, again, this, all the positive numbers, so it never really touches the 0, but just above 0 is the beginning of the positive numbers, and then it goes all the way to positive infinity, obviously grows as an exponential. That's if a is greater than 0, meaning it's a positive exponential. If it's a negative exponential, the opposite happens. So the range is all the set of negative numbers, from just below 0 on the negative side, all the way to, minus infinity on y. Okay? And the graph contains the point 0 and a, which is the y-intercept. Okay? The y-intercept of the graph. The graphs of y equals ab to the x power and y equals a times 1 over b, parentheses to the x power, are reflections across the y-axis. Okay? To graph the exponential function, we use ordered pairs, so sets of coordinates of x and y, and connect them with a smooth curve. Let's look at some examples. Sketch the graph of y equals 3 times 4 to the x power. State the domain and range. So make a table of values, right? So for x, so y equals 3 times 4 to the x. For x at minus 1, we get 3 times 4 to the minus 1, which is 3 over 4, so 3/4. For 0, 4 to the 0 is 1 times 3 is 3. For 1, 4 to the first power is 4 times 3 is 12. For 2, 4 squared is 16 times 3 is 48. And just proceed to plot these points or these coordinates, right? So at x equals minus 1, we have this should not go up like that, right? This should just keep falling down. Okay? So at x equals minus 1, we have y equaling 3/4. Well, let's move it a little bit here, right? So this is like 3/4. Okay? For x equaling 0, we have y equaling 3. So the intersection should be somewhere here, right? 3. For x equaling 1, plus 1, y should equal 12, right? It's not exactly right above it, but you get the idea, right? For x equaling 2, y should be all the way up there. You know, it doesn't really turn like that, but it just goes all the way up like that. So y should be like 48. Okay. This does not have to be up to scale. The point is just to show the idea. All right. So the domain is the set of all real numbers. The range is the set of all positive numbers. Okay. Let's look at the next example. Graph y equals 3 to the x. Make a table of values. So y equals 3 to the x. So we have for x equals 0, 3 to the 0 is 1. For x equaling 1, 3 to the 1 is 3. For x equaling negative 1, 3 to the negative 1 is 1/3. Connect the points with a smooth curve. So at negative 1, we have a negative 1 for x. We have negative 1/3 for y. At 0 for x, we have 1 for y. No, I'm sorry, this is not negative 1/3, this is 1/3. Okay, so this is 1/3, and then 1, and then at x equaling 1, y should be 2, 3. Y is 3. Okay, so this is the curve that we get, and it just keeps increasing exponentially. All right. Here we have some exercises. Please pause the video, work on these, and come back for the solutions. Okay, so we need to graph these functions. Y equals 5 to the x. So again, start by making a table of values, right? So at x equaling -1, y should be 1/5. At x equaling 0, y should be 1. At x equaling 1, y should be 5. Okay? And then just proceed to graph this. So -1, 0, +1. At -1, so let's say we have 1, 2, 3, 4, 5. Okay? So -1, y should be 1/5, so somewhere here, right? At 0, x equals 0, y should be 1. At x equals 1, y should be +5. So this will go like this. Oops. Let's try this again. So drawing manually on a screen can be a little hard, but again, the goal is to just show the general trend in the graph. Okay? And this will just keep going. I don't need the arrow. Okay? And it'll just keep falling down until it will remain asymptotic with the x-axis. Okay, next exercise, we have y equals 1/2 times 2 to the x. So again, make a table of values. We have x, and we have y equals 1/2 times 2 to the x. So for x at -1, we have 2 to the -1, which is 1/2 times 1/2, which is 1/4. For 0, 2 to the 0 is 1 times 1/2 is 1/2. For 1, 2 to the 1 is 2 times 1/2 is 1. Let's take another value just to make the graph look nicer. 2 squared is 4 times 1/2 is 2. And let's graph this. Right? So -1, +1, plus 2. 1 and 2. So at minus 1, we have a quarter for y, so it's a little bit up here, right? At 0, we have a half. Oops, I erased this. Yeah. So at 0, we have 1/2 for y. At plus 1, we have 1 for y. At 2, we have 2 for y. Okay, so it's increasing a little bit slower, but it does increase exponentially like this. Okay. All right. Hopefully this was clear. This is it for this concept. See you in the next video.